how to make some graphs for publications or for data visualization or any presentation that you want to do. So we're going to use the same data set because it's already organized data, so it won't give us time to fix on something. So the first plot that we're going to make that now is scatter plotting for the iris data. So now you use the iris where you call the function ggplot, which gives you the scattered block or normal distribution of the sample x and y. So the iris data set, so you give it the data, any data set that you work with, then you use the AES for the x and y, to set x and y. And also you set the color. So the color is usually the group. If you have you study 2-3 different groups in your data, or you have categorical data, and you want to see which group is how your groups behaves in the data. Are they similar or not similar? So you set the color by the species. For example, this database, the data set, we use the species, which is 3 species that we have. So I I set it as scatter plot 1 for the scatter plot. Then you add the geom point, was the squares inside the image. So this is how it comes out. So if you see the species, that we have 3 species with 3 different colors, because we set the color by species. If you're dealing with data was positive and negative, use the positive and negative, then you'll see different reads that comes out for the machine, or if you're running experimental, you set with positive and negative, it comes out, the values how it comes out. Each group, they are similar, they should cluster together. So for example, for the vertical and pregnancy, it's clustering together. You can see all this green and blue, they are together. So they are similar value and similar read in the CSV file, in the data set. They are similar value. But they are different from sequences. You can see the sequences in terms of width and length, it's shorter but more width. So you can export this figure. You save it as an image, as we did earlier. So you save it as an image. It will go same directory, training 2024, and you can change the size of the figure to let's say 700 by maintaining the aspect ratio. Must be intact because otherwise the image won't come right. So the format of the image is here. So now we have the image figures because I set it 700, that's when it comes. If you don't want to save it by export, you can save it with gsave, which is function from ggplot. gsave comes from this package, ggplot. So you give the name of the plot that you want to save your figure under.
I would just say that I would advise them to get used to choosing a DPI above 700 though, because the publication.
Yeah, it was here.
Huh?
You mean the DPI for the figures, yeah?
Because I normally see 700 over. So they might as well never choose something.
Yeah, I'm gonna change it. This is now 300. So you give the plot name. Then which plot you want? If you are working with, like, you're generating 5-6 plots, you have to find the name of the plot that you want to save. Then define which is the format of the plot. Then this is the size, like the height and the width. Then you specify the DPI as please save, let's say 700. So let's say 100. So it's same plot, but with lower DPI, which is not. When you print it, it won't be like high resolution, high quality image. So you get this one is 700 DPI. So it's, you see how it's clear, yeah? And this one will be 100, yeah? You see in the name of the file, it's 100 DPI. So you can control the DPI when you are saving the plot. So GT save, you give all these names and size and format of the image. Then the last thing you do, you specify the DPI of the image. So now we're using same code as this one, but you want to add the label to the plot. So let's call it. Scatter plot 2. You will see the label that comes in the top. Label of that plot comes here at the top. So now you have the title of descriptive title of the plot. So you can have more control of the size of the font size and everything, all the label and text in that plot. We're going to save this plot as well. You can add the function inside the smooth, which is draw the line in each class or each group. It's called smooth. So it gives you the line. Shows if you can see that two groups that we say they are similar, they are crossing each other, the green and the blue one. But the other group, which is the red one, it's different from that first. So now the difference here between the geosmooth, the gray side of the line. So you can move it by setting the geosmooth parameter, which is SE false. Here, using this one to remove that gray side from the geosmooth. So if you, and same, the G-smooth, if you set the method, you set it to LM, so the line becomes straight for the G-smooth. The line comes straight. You still see the green and blue groups, they are crossing each other. So you have the general alpha, which is the color, controls the color. So now here you can use the box plot. GG plot. You give the data, then you give X the species. Usually X takes the groups. Takes the groups of your data that you are comparing or performing analysis with. Then you take any variable that you want to investigate or to check the difference in that by using the box plot. So it comes like that because we don't specify any color or anything. It comes clear like that. nodes, so you have just the species as in the scatter plot. It will gives you like that. Or you can see the outlier samples. And you can see as well. So we also can plot histogram. You can make histogram like this. So just by you give the data, ggplot iris, then you set the geo as histogram, then you give the x, which is x1 column cross all the species, across all the data set. So now we add the color by the species, same as we saw in the So this is the histogram. You can see the blue and the greens mixed. So even the length, the split length, it's start from 5 and 5. And also you see here, you see how it mixes here. It's still mixed there by the histogram. And their features are more or less similar, like similar features, similar species. So we can use also the frequency. So frequency line. So also you can plot the density like that. Plot the density. You can change the transparency or the darkness of the color to make it a little bit thin. Just to see through how many, like, the overlaying. You can also increase the range here by setting the X level. See from 0 to 10. If you set it 0 to 10, 0 to 20. set it to 0 to 10 or 0 to 20. So if I take whole script, so all these plots I'm gonna delete them. So now if you go down to the terminal here and you want to run all the script as bash script, so you still find all the automated process. Like, I mean, if you have standard metadata and you add example later, like every week you add example, you can generate this before the bash script. Stay as a standard bash script for data visualization section in the report or any use. Like, as the data increase, the things are changing in the plots and you can see the difference.
Question. Yeah, how do you take out the gray background if you want the plots to just have transparent? Yeah, those
You
gray
get
box.
this one.
Yeah, they're gray.
So you move the background by you make it last one. Put GG floor. Last. So now this is the introduction to the GG floor. Can everyone run it now quickly? You have the script, yeah?
Yeah.
We'll find this book. Did you finish with this file? Is everyone finished with this file? This one. No, the script file.
If you are following him and you're up to date, please put a green sticky up. If you are falling a little bit behind or you're stuck, please put up a pink sticky.
And we have to move it a bit faster. So if you open the link in the presentation, the epidemiologist handbook, I find this book is very useful and it's available. So now, cleaning data and core function. So if you see the functions here, if you see in the table, Is everyone open this? Did you open this one? Yeah. So now the function that the most used function, the data cleaning. So if you see here, it's called file, which comes from migrate, and mutate comes from label, create, transform, and redefine columns. You see the function and the utility and the package that contain that function. Tidy select, function use logical to select column, tidy select. So even filter, keep certain rows. So all these packages comes from the player, and you can go through it. So we need to load all these packages, and maybe we need to install some new packages in this list. So first of all, can everyone try to use the install packages Batman package, yeah. Can everyone do this now? Open a new R script. Just install the action package. There's no problem with installation. Maybe because I already installed, so you installed it. So then we can move to the So because I already installed all these packages, and I will see if there's anything missing. So I use the function preload all these type of packages, and it make it accessible in the environment. So for me, it's installed. So can everyone use this one? So in the morning we use the read CSV or read XL to read the Excel files. But here we use the other function, which is import the file, which is we can use in this tutorial. We're going to use import. So there is different way to read the file, which is import, read CSV, read Excel file, read the text file, compatible for different type of files. So the data we're going to use in this example, it found under section 8.3, which is a line list, called line list. If you So the file is downloaded and it has to be in same directory. Otherwise, if it's saved in the data directory, you can read it by data/name of the file. So we can go line list list underscore equal line list import line list XLSX. So if you say dim dimension of line list, you will see 6,000 rows with 28 columns. Before we move forward, can we try and use same create report to see if there is a missing value at all? To check the data, if the data is already clean, or we have to do modify and clean. Same word directory. So see get GW. No, this one you download it. In the hyperlink, it will install the file and store it in the same directory, the current work directory. Okay. So the file we're gonna work with, it's here. Line list. The one who finished installing the file, can you create it after you install the packages, you read the file, then you create a report. Just I want you to see how many missing value and if it's possible for you to work with the data like that or not. So if you create a report from the data just to have general look at the data and you see if it's possible to work with it or not. So you see the amount of missing values. Missing observations, 7.7% out of the complete data set was supposed to be 158,000 raw observation. Huh?
Can you just slow it down quickly?
Everybody managed to get this report
No,
and see the missing values.
so it's reading in the fast. Sure.
And also,
Just having issues with the file is not reading in because it's in a different format. I'm just
descriptive, or they call it view here, descriptive table or view of the data. So every package is trying to gives you better visualization or better insight of the data. So you write this schema, scheme, line list row.
So
So if you type this function, you will get this table. Did you write this function? Yeah. Enter. You don't use space when you finish with the. Yeah. Use enter. Delete. One line. No. Before you finish. Yeah. Before you finish it. So. Maybe space. Different keyboard. Yeah, you type the data line list row. Yeah. Enter. No, yeah, control enter. Function to write descriptive table for the data set. So then I save it as data frame. Then I write it as a CSV file. Then I can open it. So you can see the scheme variables.
Can you make it bigger?
You can see this scheme variables, which is the header of the data set. What is the header of the data set? So now everyone managed to create this table, yeah? After you installing the data, can you run all the highlighted? After you install the data, can you run all the highlighted lines? After you download the data, yeah? So, okay, so now just close your just give it a name. So, GPAO.
Yeah, it's plenty of that. So pseudoform, c'est impossible. You guys just
few days. Class data, class, check what the time of so I want it as a data frame, then you write it as a CSV file. You get it as a data frame, then you write it as a CSV file.
Did you not have one of these dependency errors when you stored these packages? Was yours set up a long time ago? Maybe he had done this a long time ago. I'm thinking we should maybe get them to turn the aircon, change the aircon again. So you can start with that as you can start
So now after creating the report, you see the data is not really clean and it needs a lot of processing before you can analyze. So we start with the call names. It's supposed to be short name and you are not you don't use space when you're writing the call name in the data frame. Because for our to check the header name, you can write names, line list. So can anyone tell me if this data is named properly or not? The headers. These are at the header of the data set.
the name, are there any problems with the names? Yeah. Or how many problems can you see with the names?
Space. Infection date, date on set.
Okay, look at that.
Gender is not nice. Three dot, that means three, I think it's not displayed.
What?
So for you to work with R, you don't use for it to use header name with space, or start with the numerical, start with the number.
No. You restart it on, which means it counts everything. You said yes to restart it on.
So you can even see the book, they mention, they explain more how to name and how to process the data and what you should consider when you design the metadata for your analysis. So now we do automated cleaning.
And I'll go back to your and then you get your response. Yeah. And you went back to the yes. So you don't orange. Put on a line, type skip on. Alright, okay. And now copy and paste the whole thing. Sorry, comma after tag. Okay, so now copy the whole pattern email. Stay right hand. To the value. Yeah, copy. The down bottom. So you see the thing with Pac-Man is that it installed first.
So now,
so it combines this installed. So now now you combine the lines of
so the gentle cleaner,
Can you expand your window so we can see a few more lines of your code at the same time?
so now after you see the header, there's some header name, it's not named properly. Contain underscore space. So there's a function which is you can write just clean name. Then it puts underscore for all the headers that missing underscore has space or unnamed properly. By this package, which is called join. So you can see first, this is the raw data. You see the header have name, and you see when you write clean names, you see how it's changed automatically. So now you can use the manual cleaning. You can use the manual cleaning for the date of infection, date of hospitalization, and date of outcome. Date outcome. So you have the code in the tutorial. Date infection to infection date, and date of hospitalization, and you make a application for hospitalization to hospital, which was key.
So what you want is the end result. So I can see this is the end, this is the name of your endpoint. This is the start. So now it's going to say what's the first thing there's two separate steps of your running. And that's going why is it So what is the code is saying? The first important in this mess.
So did you finish with the first manually name cleaning?
Yeah, because you are using the same name. See the first one we did, when we did this automatically, we did it automatically. Sure, what's on the list for every client. That's for the
Just open the space.
Yes.
You see it all around.
In age, you're gonna data finish clean this one.
Yeah.
That's for this one.
So this is change.
This one.
Yeah, but I'm saying that some it's still going to be like next to so
Yeah,
yeah,
I understand.
so what we did here, this
No. It will change. It will change. Rename, change. Same color. And rename it with a new name. So then you see the infection date, it tells true. Date infection. And the hospital, date of hospitalization changing to hospitalization date, but with abbreviation, because you cannot typing the long names and the head name. It's not that fast. So now you can rename by the position of the row. New name or first column.
This is the So I think it was saying change this. Okay, yeah. So it's actually so you'll see data. So I thought it was doing this to this and doing this to this. But you understand how they are exactly what they do. So this rule is the and this is the out. Rule is the
You can also use select to rename the columns.
It's not good to start with that's why the case. So this dot that's not what we can name for it. It's just using later. The variable doesn't start with the start with the later. And it also doesn't start with punctuation. So this is not big, this is not big, this is not. So since you pull the dates on here, so these that's I think it's called up or it's listed. Oh, yes, we can go back to the full page.
Now you select the specific columns from the data using the select function. Columns. Using the bar, then you select the column of interest, like I mentioned, the column that you need for your analysis. Instead of reading and writing all the data set. So it's also there is another function you can add. You select two as you want to do first column. So here, what's the difference between this one and the previous one? Here you collect the date on set and date of hospitalization. And when you type everything, that means takes all other columns. So now there is other condition where is line list type select. Now you're modifying the data and select only the columns with the numerical values. So we have different column names with the date. Date of death, date of onset, date of hospitalization, I think. Date of hospitalization. There is 3 columns with the date. So now you will see how you select all the columns with the date. So if we run this one quickly. We have the date of infection, date onset, date hospitalization, and date outcome. So now we really saw the buy as all. So now he's selecting just by not providing the complete name. So line list by select matches. So what is matches to? Onset, hospital, fever. You don't write complete name. Just just write the abbreviation of the name, then it should pick it up from the column names in the data set. Because hospital twice, and he write it as a hospital or hospital. He write it hospital. Put it twice here. You can see only 3. He select 3, but hospital is mentioned twice and it's selected twice from the data set. So it gives the data set. So now if you want to create data, we call it data 2. You assign your action under data 2 to save it. And just remember to move the name, because this is means that it only take the name. So like that it should work. So let's then data 2. So we have 4 columns, which that we select. Start with onset, hospital, which is twice, and fever. So now you have subset of the original data. So here, any of. So if you're providing 10 headers and it's only 5 there, it won't give error back. It won't give error back. It will run and pick up only if some of header that you provide exists in the data set. Same as the example here. It's only onset is there, date of onset. These columns are, these headers are not there. So minus C, select minus C, then you pass the header to remove the column from, or indicating columns to remove, which is column need to be removed. So I think today we'll stop here.